Section 1.2, linear equations. To solve an equation, you want to get x by itself. You have to do the same thing on both sides of the equation. So on the left side, we're going to distribute the 2 times x, 2 times minus 3. Keep those equal signs lined up all the time. On the right side, that minus 3 times, we multiply before we do that subtraction. So we're going to distribute negative 3 times x and negative 3 times negative 2. I'm going to combine the like terms, minus 6 minus 17, and 13 plus 6. Okay, we want to get x by itself. X is on both sides, so I'm going to cancel out that minus 3x by plus 3x. Keep that equal sign lined up. Now I add 23. Five x means multiply, so I divide. That doesn't divide nicely, and nothing divides into both of those, so that's your final answer. An application of solving in equations is the accounting equation, which says assets equals liabilities plus owner's equity. And we're given that assets equals 10,000, owner's equity equals 3,000, and asked to find liabilities. So we can solve for that by just subtracting. So that tells us that liabilities would have to be 7,000. Fractions with number denominators. You can multiply everything by the common denominator to get rid of the fractions. So 2 and 5 go into 10. So I'm going to put a times 10 beside everything. So everything's getting a times 10. I'm using 10 over 1 since they're fractions. Okay, now you can cross multiply or you can just multiply. So I'm going to say 10 times 3x is 30x, and 1 times 2 is 2. 10 times x and 1 times 5. 10 times 39 and 1 times 5. Or you can cross multiply. So then you get nice divisions. So 30x divided by 2, 10x divided by 5, and 390 divided by 5. Okay, now we got x on both sides. Never cancel one side. So we're going to subtract 2x on both sides. And then divide by 13 to find out what x equals. Okay, another one with fractions. Okay, we're going to multiply everything by what they go into. 4, 3, 6 can all go into 12. So everything's going to get a 12 over 1. Okay, you can cross multiply, like 4 goes into 12, or you can just go ahead and multiply tops and bottoms. 12 times x, 1 times 4, 12 times 2x, 1 times 3, 12 times 5, 1 times 6. So now I'll have good divisions. That's the reason we multiply by 12, is because it will make that fraction not have denominators. 12x divided by 4, 24x divided by 3, 60 divided by 6. Okay, now 3x is on the left. Normally I do the smaller x to get rid of, but never cancel out a whole side. If you subtract 3x, then there won't be anything there. Instead, we're going to subtract 8x on both sides. Okay, we need to divide by -5 so that the 5 and the negative divide out. Okay, we need to divide by -5 so the 5 and the negative cancel. Positive divided by negative is negative. Okay, another application is estimating your utility bill. For example, in June, the usage for utilities was $16.79. It's called kilowatt hours, but you don't really need to know that. And the bill was $166. So I go out in July and I look at my meter, the same time, same day that they read it every month, and I see how much I've used from the previous reading, and I see that I've used a little over 2,000, and I'm trying to estimate my bill. So that's going to be X. So June, the bill was $166 for a usage of $16.79. And I want to know if the rates are equal, like if the dollars per usage are equal, what my bill will be based on a usage of a different number. Okay, on that right side, X is being divided. We undo divide with multiply. So if I multiply by the same number on both sides, I'm going to put that over an understood 1. Then it cancels on the right side to give me X. So I'm going to multiply 2037 times 166. And then on bottom, 1 times 1679. That gives me X on the right since those canceled. Divide, okay, that tells me the bill should be about $201, okay? It's a way that you can use equations to estimate a bill that is based off of usage, like water bill and electrics. Okay, fractions with letters in the denominator. Okay, what is always true? Cannot have 0 in the denominator. Okay, so if we have an equation that has letters in the denominator, the first thing we do is find out what X cannot be. X cannot be 0 because if you plug 0 in for X, you would have 0 on bottom. Okay, now we're going to multiply by the common denominator. If we take 5 times 2x, we get 10x. And if we multiply everything by 10x, those x's will cancel out. So I'm going to multiply everything by 10x over 1. Okay, I'm putting it over 1 because everything's a fraction. Okay, now we're going to do some canceling. Okay, whoops, I didn't mean to erase. Okay, I'm going to do some canceling. This x and this x. And then on the far right, that x cancels with that x. Okay, now I'm going to multiply straight across. 10 times 1. The x is canceled, so that's just a 1 there now. Okay, 10x times 1 and 1 times 5. 10 times 8 and 1 times 2. So when I do these divisions over here, we'll see that I have a fraction. I have fractions gone. No more fractions. Okay, so now I need to solve for x. Okay, I just have x on that right side, so I need to get rid of the stuff with the x. Oops, sorry, I don't know what I'm doing here. Okay, so let's subtract 40. And then divide by 2. Okay, so I found that x couldn't be 0, and x does equal negative 15. In my math lab, okay, just enter the number. You don't put x equals in, you just put in the number. Okay, next we have another equation. This time x can't be 3 because if you put 3 in the bottom, you get 3 minus 3 equals 0. We can't have that. Okay, now we're going to multiply by the common denominator, which is x minus 3. So everything's going to get times x minus 3. Okay, so everything is getting times x minus 3. Okay, on the left, I did it again. I hit the eraser instead of highlight. Okay, cancel here in the middle, but there's not one underneath the 9, so there's nothing to cancel. So on the left, it's x. In the middle, it's 3. And we're going to distribute the 9. 9 times x. 9 times negative 3. These are like terms. 3 minus 27. I've got x on both sides, but I don't want to cancel x because then there wouldn't be anything over there. So instead, I'm going to cancel that 9x. So I get negative 8x equals negative 24. Divide. Okay, but what did we say in the beginning? X can't equal 3. Whenever what x can't equals what you get, that means there's no solution. Okay, and sometimes you'll see the 0 with the line through it. when what x can't equals is the same as what you get, that means there's no solution. Okay, we've got x in the bottom, so what can't x be? What minus 7 equals 0? 7. So x can't be 7 because you can't have 0 in the bottom. Okay, now I'm going to multiply everything by the common denominator, which is x minus 7, because that's the only thing there, the only denominator. Okay, whatever you multiply by, you've got to do the same thing to everything. Okay, on the left, the x minus 7's cross out. On the far right, they do also. So this just leaves me 4. I'm going to multiply that 1. One times anything is itself, and that just leaves me 5 over there. 4 minus 7 are like terms. I add 3 to both sides, so x equals 8. Okay, now it's fine for x to equal 8 because it just can't be 7. Okay, one more thing. Let's talk about what x equals 8 means. What does it mean that x equals 8 is the answer? Okay, it means if you take 8 and put it everywhere there's an x, it should be true. Okay, 8 minus 7 is 1. 8 minus 7 is 1. 4 over 1 is 4. 5 over 1 is 5. Does 4 plus 1 equal 5? True. Okay, that's what it means. It means when you plug in 8, it's true. It's a true equation, which 5 equals 5, that's true. And that's the end of our lesson.